Dear students, so in previous class, we tried to prove that the differential equation y square equals x cube plus k has no solution if k is of the form 4n minus 1 whole cube minus 4m square. So, we already proved it. When x is even and y square congruent to 0 mod of 4, when x is even and y square congruent to 1 mod of 4, when x is congruent to minus 1 mod of 4 and y square is congruent to 0 or 1 mod of 4, all of these cases are not possible. Finally, we obtain x square plus ax, so x square plus a square minus ax is congruent to minus 1 mod of 4. X square plus a square minus ax congruent to minus 1 mod of 4 means this x square plus a square minus ax is odd. Okay, x square plus a square minus ax is odd. Then, thus x square plus a square minus ax congruent to minus 1 mod of 4. This gives all prime factors of x square plus a square minus ax, x square minus a square plus a square minus ax is odd. Then if it congruents to minus 1 mod of 4, that gives all prime factors of this x square plus a square minus ax can be equal to 1 mod of 4. Why? If it possible, let it have some prime factors p1, p2, p3, etc. And if pi congruents to 1 mod of 4, what happens here? Pi congruents to 1 mod of 4, then the products p1, p2, etc. pm congruents to 1 mod of 4. That means x square plus a square minus ax congruents to 1 mod of 4, which is impossible. Agreed? So, x square plus a square minus ax congruents to minus 1 mod of 4 always gives that the prime products of this x square plus a square minus ax can be equal to 1 mod of 4. Agreed? Therefore, thus there exists some prime p such that p congruents to minus 1 mod of 4, p congruents to minus 1 mod of 4 such that p congruents to minus 1 mod of 4 which divides x square plus, which divides x square plus a square minus ax if possible. Thus, there exists a prime p that p congruents to minus 1 mod of 4 which divides x square plus a square minus ax. That means p divides x square plus a square minus ax. So that implies p divides x square plus a square minus ax into x plus a. Okay. What about the right side? That means what about this quantity p divides x square plus a square minus ax into x plus a? We see that it is x cube plus a cube, that is y square plus 4m square. Okay, y square plus 4m square. We already see that this x square plus a square minus ax into x plus a is y square plus 4m square. So finally p divides y square plus 4m square. P divides y square plus 4m square means, what is y square? That means y square congruents to minus 4m square, y square congruents to minus 4m square mod p. Okay, so for some prime, there is y square congruents to minus 4m square mod p for some prime p congruents to minus 1 mod 4. Clear? But it is given, according to the hypothesis, there is no prime p congruents to minus 1 mod 4 which divides m. That's our hypothesis. There is no prime p which congruents to minus 1 mod 4 divides m. Thus p does not divide m. Okay, that is by hypothesis. P does not divide m. Now consider minus 4m square by p. Minus, what is minus 4m square bar p? Minus 4m square by p equals, it is minus 1 into it is 2m whole square by p. Agreed. By multiplicity, that equals minus 1 bar p or minus 1 by p into 2m whole square by p. When m and p are relatively prime, m square by p is 1. Here also 2m and p. P is an order prime, 2m is always even, so 2m and p are relatively primes. Therefore, what about this 2m square by p? 2m square by p equals 1 itself. So, which is nothing but minus 1 by p. What is minus 1 by p? When p is an odd, minus 1 by p is minus 1 power, evaluation of minus 1 by p, it is minus 1 power p minus 1 by 2. Since p is an odd, p minus 1 is even, so it is p minus 1 by 2, that equals 1 itself. Okay, so that means minus 1 by p, so that equals minus 1 power p minus 1 by 2, so it is minus 1. That means minus 4m square by p equals minus 1. So by Legendre symbol, when n by p is minus 1, if n is quadratic, non-residue mod p. So here 4m square is quadratic, non-residue mod p. Minus 4m square by p is minus 1, means minus 4m square is quadratic, non-residue mod p. But we have y square. What is y square? Y square congruence to minus 4m square mod p. Minus 4m square mod p. That means y square congruence to minus 4m square mod p means minus 4m square is quadratic residue mod p. That is a contradiction to this argument. Hence, we say that there exists y square equals x cube plus k has no solution if k is of the form 4n minus 1 whole cube minus 4m square. So this completes the proof. Agreed. That means the Diophantine equation y square equals x cube plus k has no solution. There exists no solution whenever k is of the form 4n minus 1 whole cube minus 4m square. Agreed. Okay. Now consider a problem. Let P be an odd prime. Let P be an odd prime. Then prove that sigma over R ranges from 1 to P minus 1, 1 to P minus 1, R by P equals 0 if P congruence to 1 mod 4. Let P be an odd prime. Let P be an odd prime. Then sigma R ranges from 1 to P minus 1 R by P equals 0 if P congruence to 1 mod 4. How? So listen, here PR and P minus R runs through the numbers 1, 2, 3, etc. to P minus 1. R and P minus R runs through the same numbers. R and P minus R runs through 1, 2, 3, etc. to P minus 1. Okay. Also, we have R by P into, or we have, since R and P R runs through, R and P minus R runs through same numbers 1, 2, 3, etc. So we have R by P equals minus 1 power P minus 1 by 2 into P minus R by P. Okay. Why? Because R and P minus R runs through same numbers 1, 2, 3, etc. up to P minus 1. R by P equals minus 1 power P minus 1 by 2 into P minus R by P. Okay. Right. Now, so what is P? Since P congruence to 1 mod 4, P congruence to 1 mod 4 means P minus 1 by 2 is even. You also see that P congruence to minus 1 mod 4. Sorry, P congruence to 1 mod 4. 4 divides P minus 1. Okay, P minus 1 is a multiple of 4. P minus 1 by 2 is a multiple of 2. Means P minus 1 by 2 is even. No doubt. P congruence to 1 mod 4 means P congruence to 1 mod 4 means 4 divides P minus 1. Means P minus 1 is a multiple of 4. Okay. So what is P minus 1 by 2? P minus 1 by 2 is always an even number. Multiple of 4 means suppose it is K into 4. So it is K into 2. Okay. P minus 2 equals multiple of 4 means some 4 into K. So sorry, P minus 1 is 4 into K. So what is P minus 1 by 2 equals 2K means it is even. P minus 1 by 2 is even. So from here what is R by P? Here R by P is minus 1 power P minus 1 by 2 is even means it is 1. So it is minus, so it is, come on, R by P is P minus R by P. When P congruence to 1 mod 4, then R by P is P minus R by P. So what about therefore sigma R ranges from 1 to P minus 1 R by P equals, since R and P minus R runs through same numbers 1, 2, 3 is up to P minus 1. So it is sigma R ranges from 1 to P minus 1. It is R by P is rewrite as, sorry, not R by P, the question is R into R by P. Sorry, the question is R into R by P. Okay. Sigma R ranges from 1 to P minus 1 R into R by P equals, R is replaced by, so it is P minus R into P minus R by P. Okay, why? Because R and P minus R runs through same numbers 1, 2, 3 etc. up to P minus 1. Sure? Okay. Do you have any doubts? Listen, what is sigma R? When R ranges from 1 to P minus 1, sigma R equals, sigma R ranges from 1 to P minus 1, P minus R. There is no doubt. Why? When R equals 1, 2 etc. up to, so this is 1 plus 2 plus 3 plus etc. up to P minus 1. What about this one also? P minus 1, P plus P minus 2 plus P minus 3 etc. That's in reverse order. Okay. So it is sigma R ranges from 1 to P minus 1, P minus R into P minus R by P. That is sigma R ranges from 1 to P minus 1, P minus R into, what is P minus R by P? From here, P minus R by P is nothing but R by P. Okay? R by P. That equals P into sigma R ranges from 1 to P minus 1 R by P minus R into sigma R ranges from P minus, sorry, not R, as minus R into minus sigma R ranges from 1 to P minus 1 R into R by P. Clear? Can distribute. Why? Because of the multiplicity. What about this one? This is always 0. P into sigma R ranges from P minus 1 R by P is always 0. Sure. Do you have any doubts? Let's prove by an example. If P equals 3, suppose P equals 3, then it is 3 into, what is the first term? R equals 1 to 2. Okay, P minus 1. So it is 1 by P plus 2 by P. Enough? What is 1 by P? 1 by P is 1. Plus what is 2 by P? 2 by P, variation of 2 by P, minus 1 power P square minus 1 by 8. 3 square, 9. Minus 1, 8. 8 by 8, 1. So 1 minus 1, 0. Any P. For any order prime P, we have P into sigma R ranges from 1 to P minus 1 R by P is 0 itself. So this term reduces to 0. So what do you get? That means sigma R ranges from 1 to P minus 1 R into R by P equals minus sigma R ranges from 1 to P minus 1 R into R by P. So that means bring this one to the left side. So that means 2 into sigma R ranges from 1 to P minus 1 R into R by P equals 0. So that means sigma R ranges from 1 to P minus 1 r into r by p equals 0. So for any order prime p, then the result is important. For any order prime p, sigma r ranges from 1 to p minus 1, r into r by p is 0 if p complements to 1 mod 4. Enough. So consider another one. The result is important. So come to the next result. Let p be an order prime. The first result is let p be an order prime. Then sigma r ranges from 1 to p minus 1, r into r by p equals 0. This is the first result. Second one, if p is an order prime, then prove that sigma r ranges from 1 to p minus 1. Sigma r ranges from 1 to p minus 1 r equals p into p minus 1 by 4 if p complements to 1 mod 4. If p complements to 1 mod 4. When p is an order prime, then sigma r ranges from 1 to p minus 1 r equals p into p minus 1 by 4 if p complements to 1 mod 4. Again, when p is an order prime, then surely for r and p minus r runs through the same numbers 1, 2, 3, etc. up to p minus 1. Okay. Therefore, we know that r by p equals minus 1 power p minus 1 by 2 into p minus r by p. Clear? When p complements to 1 mod 4, we also see that p minus 1 by 2 is always even. So that means r by p, here r by p equals p minus r by p. Agreed? Okay. Therefore, sigma r ranges from 1 to p minus 1 r equals sigma r ranges from 1 to p minus 1. What is r? P minus r by p. Agreed? That equals sigma r ranges from 1 to p minus 1 p minus sigma r ranges from 1 to p minus 1 r by p. Okay. That equals p, that means sigma r ranges from, yes, sorry, there is a mistake. Sigma r ranges from, yes, sigma r ranges from 1 to p minus 1 r equals sigma r ranges from 1 to p minus 1 r itself. Sorry. That equals sigma, that means this equals sigma r ranges from 1 to p minus 1 p minus sigma r ranges from 1 to p minus 1 r. Okay. So from here it is that means sigma r ranges from 1 to p minus 1 to r. 2 into, bring sigma r ranges from 1 to minus sigma r ranges from 1 to p minus 1 r to the left side. So 2 into sigma r ranges from 1 to p minus 1 r equals here p into sigma r ranges from 1 to p minus 1 1. Means addition of 1 means add 1 p minus 1 times, that equals p into p minus 1. P into p minus 1 by 2. P into p, yes, p into p minus 1 by 2. So it is sigma r ranges from 1 to, that means, so if p complements to minus 1 by mod 4, so it is sigma r ranges from 1 to p minus 1 of r equals p into p minus 1 by 4 by evaluating this one. Okay. Now, come to the next problem. Let P be an order prime. First result is let P be an order prime, then sigma r ranges from 1 to p minus 1 r by p equals 0. Now next we prove that let P be an order prime, then sigma r ranges from 1 to p minus 1 1 to p minus 1 r square into r by p. R square into r by p equals p into sigma r ranges from 1 to p minus 1 r into r by p. R into r by p if p congruence to 3 mod 4. If p congruence to 3 mod 4. So listen, this happens only when p congruence to 1 mod 4. If p congruence to 1 mod 4, what about this result? Result should be 0. So sigma r ranges from 1 to p minus 1 r square into r by p equals p into sigma r ranges from 1 to p minus 1 r into r by p only when p congruence to 3 mod 4. How? So again we have r and p minus r runs through the same numbers 1, 2, 3 etc. up to p minus 1. So we have r by p equals minus 1 power p minus 1 by 2 into p minus r by p. Agreed. But p congruence to 3 mod 4 means p minus 1 by 2 is odd. Sure? Already we see that when p congruence to 3 mod 4, p minus 1 by 2 is odd. So what about r by p here? R by p equals minus of p minus r by p. Agreed? Okay. Now, what about sigma r square into r by p? Sigma r square, where r ranges from 1 to p minus 1, r square r by p equals sigma r ranges from 1 to p minus 1. What is r square? R, you can replace r by p minus 1. R and p minus r runs through same numbers. P minus r whole square into p minus r by p. Okay, p minus r square into p minus r by p. But what is p minus r by p? That is minus r by p. So this left side equals sigma r ranges from 1 to p minus 1 p minus r whole square into p minus r by p is minus r by p. That is from here, so there is a negative sign outside of the sum. Okay. So that equals minus of sigma r ranges from 1 to p minus 1 p minus r whole square. What do you get? P minus r whole square into r by p. That is one expansion, it is p square minus 2pr plus r square into r by p. Enough? So that means that equals minus p square into sigma over r ranges from 1 to p minus 1 by 2 r by p. Okay. Minus of minus plus 2.